Hello, today we are doing exam 2, page 9 and 10, question 6. This question is asking us to do like a position and velocity, and this is normally like a derivatives. So let me move this. Okay, let's do this. So the position of a moving particle is given by st equals t to the power 3 minus 12t to the power 2 plus 36t. Particle is moving in feet where east is position direction. Let's put that in parentheses. Oh, let's put this positive, which st has a positive slope. And keep that in mind. Okay. And t is measured in minutes. Keep in mind that time can only be positive after start. Find the first and second derivative of s of t. Okay, so s of t, we're just going to use the power rule here. So we get 3t 2 minus 24t plus 36. And we did this through the power rule. We take down 3 minus 1 minus 2 times 12 minus 1 plus 36 times 1 t to the power 1 minus 1. Second derivative is going to be, let's put it as double prime of t. Get rid of that. Of t equals 6t minus 24. Moving on. If the first derivative is the velocity equation, when is the particle at rest? So this is saying that if s of t equals v of t, so that means that v of t is going to be the equation up here. So we're going to find out when this function, because a particle at rest means that there is no velocity. So we're going to find out when this function equals 0. First thing we notice is that we could take a factor of 3 out of this equation. So let's do that. So we get t squared minus 8t plus 36 plus 12, I mean. Okay. Now we're gonna set these apart. So we have 12. So let's just take out 1 real quick, just by factoring. So what goes into 12? We have and positive. So negative 6 times negative 2, which both add up to be 8. So t squared minus 2t minus 6t plus 12. Let's take a factor of 2. So we're going to have t minus 2, that's what I meant, minus 6, which is going to be t minus 2. So now that we have that, we know that this is going to be t minus 6 parentheses times t minus 2, just by factoring it out. So since that we know that these are two separate, we find that when t minus 6 is equal to 0, t is going to be 6. And when t minus 2 equals to 0, it's going to be t equals 2. So let me erase this so we can put it up there. So you know that t equals 6 and t equals 2. Next question, algebraically determine the intervals where s of t is increasing. So this means that we're going to find when these two, since we know they're at rest, we know that their signs could be changing. So let's put it down. And this is going to be velocity. Okay, so the velocity determines if s of t is increasing or not. So let's find a value that is let's say 1. We'll go with 1, 3, and 7. When f of t, when v of t of 1, when v of t equals 1, or when the time is 1, basically is what I'm trying to say. When the time is 1, it is going to be 3 times 1, which is 3. So let's just put this over here. 3 times 1, so it's going to be 3 minus 24. It's going to be a minus sign, plus 36. So this is going to be positive, just from what we see. This is going to be a positive sign. So that's is when it's increasing. And then at 3, we're going to put 3 times 9. So that's going to be, let me think about that. 3 times 9 is 27, minus 24 times 3, which is 72, plus 36. Because there's no t here, this is going to be a negative. Just from looking at it, and adding it up. I have all the math in my other paper, just to speed it up. And then 7, we're gonna plug in 7, and we could tell when 7 is a high number, it's gonna be very high. It's gonna be like 7 times 42 times 3 minus 24 times 7. That's a big difference. So we're gonna put a positive here. So now we know when it's increasing. So when it's increasing, we have an interval of 0 to 2. Prime, or u, for the difference. 3 or 7, or I'm sorry, 6 to infinity. You always start from the intervals. So 2 to 6 will be decreasing. Moving on to the next question. On which intervals of time does a particle moving west? So now that we know that it's increasing from, let me write this down. And since we know that it's increasing from 0 to 2, u 6 to infinity, because time can be negative. We understand that 2 to 6 must be negative, because even when we plugged in 6 on the v of time, when it was 7, it was negative, and it only changes when the velocity is at 0. So this is going to be 206, and we know that west is the negative direction. Moving on what intervals of the time does a particle have negative acceleration? So we're gonna put the function down here. So if you, just to remember, acceleration of time equals the double prime of t. And as you remember, f of t was, or f double prime was 6t minus 24. So now we're gonna find out when S6t minus 24 is 0. So just some quick math. We do 2 equals 24 divided by 6, which is just 4. Because 6 times 2 is 12 and times 2 is 4, so 6 times 4 is 24. So let's put this on the graph, or the line graph. So we have 1 at 4. And just looking at the function, we know that when this is 2 and when this is let's do 3, or I mean 5, 6 times 5 is 30. So when 30 minus 24, it's going to be a positive. And when 6 times 2 is 12 minus 24, it's going to be a negative. Those are some quick observations. So now that we know it has negative acceleration, we know that when the a is when 0 to 4 is when the acceleration is negative throughout the graph. All right, last question. Using the information from the questions that we did, determine the time intervals when the particle is slowing down. So we could evaluate that when the particle is slowing down, that means that the velocity over time, let's say, is positive. In order for it to be slowing down, acceleration must be negative. So this like you can see on the graph, when the velocity versus time graph, that when you have a high velocity but it's always going down, so it's because it's slowing down, as of like you could say like right here, it's slowing down. This must mean that acceleration, because of the slope of the graph, this is positive when AT. This must mean that this is it's going to be a negative acceleration based on that graph. And same with opposite. If the acceleration is positive and this is negative, then the same thing goes around. Like if the velocity is going to a negative, is a negative in the negative side, and acceleration must be positive because it's increasing. Okay, so using the graph that we have from the previous questions. So this is going to be v over t, and this is going to be t. Just to show you guys something, we know that 2 to 6, we have a positive and a negative. I mean, a positive and a negative in the middle. And from 4, better, like lucky that we have in the middle, this is going to be negative and positive. So as you can see, there's 2 different signs here. So we're going to put a line right here and like kind of shade it in, but not really, meaning that this is slowing down. And when we have a positive, we have, it's the same here, but we have a point where it's different signs from 4 to 6. And because it's negative here and 2 to 4 is still negative, that means that it's increasing. And because these two are both positive, it means they're increasing in the same direction. So we know that when it's slowing down, the signs have to be opposite, which I shaded in. So it's going to be 0 to 2. Sorry, parentheses. U, parentheses, 4 to 6. And then there's also a statement. So this means that we could say that when acceleration and v of t have different signs. It must mean it's slowing down. Thank you for watching. And I already explained what this means, right here in the graphs. So thank you for watching and goodbye.